Today we're going to look at solving logarithms with the same base. We saw something similar with their inverse exponents. So if you can recall, if I had an exponent that had the same base, I can disregard that base and just focus primarily on the exponents. As I see here, x equals 2. So we're going to use that same strategy, but this time with logs. I have two log functions here separated by an equal sign. Log base 3 of 5x minus 1 equals log base 3 of x plus 7. Note that they share the exact same base of 3. So then I can ignore the log completely. And just look at 5x minus 1 equals x plus 7. And then solve this linear term. And I get x. So we're going to use our same strategies we had with exponentials that we're going to use with logs. We're going to see if they had the same base and then solve everything else.
Mr. Clark, can I go look for my phone, please?
I guess so.
Thank you.
Now, it's very important from here on out that we do check our work. So I get x equals 2. But as we see with logs, they are very particular. If I were to take log, and let's say put in a negative here, it doesn't care for negative numbers too much. So we need to be careful on what our x value is, especially careful if we happen to get a negative number here. So let me test. Let me see what is log base 3 of 5x minus 1 when I plug in 2. So alpha window 5 log base 3 of 5x minus 1. So 5 times 2 minus 1, and I get 2. So that one worked. But now let me make sure I get the same number on the other side. Log base 3 of x plus 7, so 2 plus 7. Alpha window 5 log base 3 of 2 plus 7. And I do in fact get 2. So, I can go ahead and accept that x equals 2 is the correct answer. Another reason why the next test should be pretty easy, you should be checking your work with all of your questions. You should know if you got it right or wrong. So, looking at another example. Log 5x equals log of 2x plus 9. I need to ask myself, to solve this, do they have the same base?
Log 10.
Log 10, very good. They do both have the base of log 10. And because of that, I can cancel out the log completely and just focus on the values here. 5x equals 2x plus 9. Now we have something a lot easier than log, which is a linear term that we should all be able to solve in our sleep. Let me subtract 2x here, 2x there. I get 3x equals 9. Last but not least, divide by 3. X equals 3. Or does it? Let's check our work. Make sure we don't get any solutions that come up as an invalid number, and make sure we get the same number on both sides of the equal sign. So log base 10, so this is one of those rare moments I actually get to use this log button. Log base 10 of 5 times x, so 5 times 3. I get that value. Now let me make sure I get the same value on the other side. Log base 2 times x plus 9, so 2 times 3 plus 9, and I do get the same number. So I've checked my work, and I've verified that x does in fact equal 3. Now let's try one more and see an example where it actually does fail. So log base 3 of x minus 9 equals log base 3 of 4x plus 7. Ask myself, do I have logs with the same base? Yeah, so I can go ahead and cancel all of that and just focus on x minus 9 equals 4x plus 7 and solve. So let me move this x over. That's going to give me a negative 9 equals 3x plus 7. Let me isolate my variable, move that 7 over. I get negative 16 equals 3x, And last but not least, divide by that 3. I get a value of x equals negative 16 over 3. Or does it? So let's check our work. Let's plug in negative 16 over 3. So log base 3 of x minus 9. So negative 16 over 3 minus 9. And what happens? Ooh! That is an invalid answer. Because it, very good, because it is negative. So, that means I have to throw negative 16 over 3 away. I don't end up with any more x values to test, so what do you think the solution is?
No.
No solution.
No solution, very good.
I was right. Thank you, big brain.
No solution.
I made it up.
There are no x values that will work for this logarithmic expression. And you might see no solution stated as an empty set, which looks like open and closed braces.